everyone, welcome to Mechanical Sathi. So today we are going to discuss MCQs from fluid mechanics. We'll be trying to cover two chapters today. There is buoyancy and flotation, and second one is fluid kinematics. So both these chapters are most important from the SSC point of view. So we'll try to cover these two today. So and we'll be covering a few number of questions from these two chapters. So if I will be getting some more questions, then I will make another video for these two chapters. So without wasting time, let us move forward. Before that, I want to tell one thing, that if you have not subscribed this channel yet, so do press on the subscribe button. Okay, do subscribe it, and press on the bell icon so that you will never miss any updates from this channel. So without wasting time, let us move forward. So moving towards the first question. So it is telling that okay, let me use the pen. Okay, so it is telling that buoyancy and flotation. Okay, so this is the first chapter we'll be discussing today. So first question is, a piece of metal of a specific gravity, that is S, floats on mercury. Okay, so mercury, which is having a specific gravity, that is 13.6. so what fraction of volume is under the mercury? So that I need to calculate. So what fraction of volume of that metal piece will be inside that mercury, we need to calculate. Okay, so if we know, so the from the buoyancy point of view, what is the buoyancy force? That will be the uh, weight of the weight of the metal, okay, that is inside the your liquid. Okay, so buoyancy force will be equal to, we can say, that is weight of the what, that metal. So buoyancy force will equal to weight of the metal. So what is that buoyancy force? So buoyancy force will be equal to rho g. Okay, so rho of what, that is hg. Okay, rho of mercury, and g, and that is v, that is vf, we can say. So vf is denoting for your, okay, that amount of volume that is inside that liquid, or here we can say that is inside mercury. Okay, so that will be equal to what, weight of the metal. So weight of the metal will be equal to what, if we will be taking rho, that is rho of metal. Okay, rho of metal into g into total volume of the metal. Okay, so we need to calculate the what portion of volume is inside that mercury. So we can say we need to calculate vf. Here g and g can be cancelled. Okay, so if we be divide your rho of hg from the rho of m, and then we can calculate the portion of volume that is inside that mercury. Okay, so that can be find out rho of mercury, sorry, the rho of the metal can be find out here. S, that is s, that is specific gravity is given, that is 7. Okay, and if we'll be multiplying with 1000, then it can be calculated. So rho of metal can be calculated. Likewise your rho of sorry, mercury can be calculated. So that will be 13.6 into 1000. So 1000 can be cancelled, and it will be the portion of b. So 7 by 13.6, that will be nearly equal to 0.515. so if we'll be writing 7 by 13.6 into b, so that will be equal to what, 0.515 v. So this portion of volume will be under mercury. Okay, so C option will be correct here. Okay, moving next. So it is again the center of gravity of the volume of liquid displaced by an immersed body is called what? So center of gravity of the volume of liquid displaced, so it is known as your center of buoyancy. Okay, so C option will be the correct one here. So let us check. So here this is the option number C. Okay, so let me decrease it. Okay, so option number C will be the correct one. Moving next, metacentric height is the distance between what? So metacentric height is the distance between metacenter and center of gravity. Somehow it is represented by mg. So m stands for your metacenter and G stands for the center of gravity. So C option again will be correct here. So moving next, so C will be the correct one. Then here, so another in between your buoyancy and filtration. So let us discuss something about liquid in rigid motion. Okay, so uh, first question is a liquid with constant angular momentum. So angular momentum is constant here, so we can write that is mvr will be equal to constant, and here m will be always constant, so we can neglect this one. If you will be taking this, then again we can write vr equal to constant. Okay, so what is telling here, we need to see that. So here okay, so angular momentum is constant. Okay, so has a tangential velocity of 1.2 meter per second at 3 that is 3 meter from axis of rotation. Okay, so here let v1 is given 1.2 and r1 is given 3 meter. Okay, and the tangential velocity at 1.5 from axis of rotation will be how much meter per second. So at r2, so let r2 is given this one, then v2 will be equal to how much, that I need to calculate. Okay, so as I told now, recently I discussed that vr will be equal to constants. That means multiplication of velocity and that is axial location. Okay, so axial distance, that will be equal to constant. So I can write v is inversely related with radial distance. Okay, so from this, if I want to write the relation in between 2 points or 2 velocities or two radial distances, then I can write v2 by v1, that will be equal to r1 by r2. Okay, so everything is given here and I need to calculate v2. So v2 will be equal to what? So r1 is given 3. Okay, so r1 is given 3 divided by your r2 is given 1.5 and your v1 is given 1.2. So 1.5 it will cut by 2, so it is given 1.2. Okay, so 1.5, so we'll be getting 2 here, 2 cross 1.2, so we'll be getting 2.4 here. So 2.4 meter per second. The option C will be again correct. Okay, let us check it. So here option C will be the correct one. So we got 3 by 1.5 into 2, sorry, 1.4, 1.2, sorry, 1.2. So if we will be dividing this one, then I will be getting 2, and if we will be multiplying with this, then we will be getting 2.4. Okay, moving next, the flow of water in wash basin through a central opening is an example of what? It is a free vortex, we can say. So in case of a free vortex force, free vortex motion or free vortex flow, there will be no extra agent, extra force is applied, and it will be occurring automatically. Okay, so here your flow is occurring automatically. So option B will be the right answer. So B will be the correct one. Then moving next, so next chapter is your fluid kinetics. Okay, so equation of continuity of flow is based on principle of conservation of mass. Okay, so equation of continuity. Okay, so that will be the conservation of mass. So option will be the correct one. Option A will be the correct one. Okay, so moving next, the equation of continuity holds good. Okay, equation of continuity holds good when the flow is, okay, what are the assumptions of equation of continuity? So what are equation that flow must be steady, and B is one dimensional flow will be occurring there, and C, this will be also the correct one. Then C is the velocity is uniform at all cross section, so uniform velocity should be there, so C is also correct one. So we can say all the above option is correct, so D will be the right one here. So here D option will be right one. So moving next, so D will be correct one here. Okay, so next question, an ideal flow of any fluid, so this is your fluid, okay, so must fulfill the following what, which law, okay, so ideal fluid of okay, that is which law it follows, so it should follow what, continuity equation again. So ideal flow should follow the continuity action, so again what, D option will be the correct one. So here also D option is correct. Then moving next, the flow between two streamlines, what happens, okay, so it will always remain same, okay, so the flow any between any two streamline remains the same, so A option will be the correct one. Okay, then moving next, a streamlined body is such that, okay, a streamlined body is such that, okay, the shape of the body coincide with the stem surface, okay, the shape of the body coincides with the stem surface, so D option will be the correct one here. Okay, moving next. Okay, then question number 6, so it is telling that Navier-Stokes equation are associated with what. Okay, so in Euler equation, what we consider, we consider that the flow is inviscid. Okay, so viscous is not taken into account. If viscosity of the fluid is taken into account, then we can say, so that is the Navier-Stokes equation. So if viscosity will be taken into account, then that type of flow is known as your, okay, that type of equation is followed by Navier-Stokes equation. Okay, so D will be the correct one here. And for question number 7, the path traced by a single particle of smoke issuing from burning wooden stick, so that will be a path line. So option D will be correct here. Again here also option D, so D, and here also D. Okay, so D is correct here also. Then moving next, a fluid is said to be ideal if it is, okay, it is so for to fluid said to be ideal, it should be inviscid and incompressible. So inviscid and incompressible fluid is said, it told us an ideal fluid, so which doesn't exist actually, no ideal fluid is there, but this is an assumption for our cases to make simple. Okay, so D option is the correct one here. Moving next, okay, so D is the correct one. Then continuity for compressible fluid, okay, so continuity equation for compressible fluid, so that is known as C option, that is rho a1 v1 and that will be equal to rho a2 v2. Okay, so in case of your compressible compressible fluid, your density will change from the state to state, so we can say multiplication of density at that point and your cross sectional that is area, okay, and b the velocity, so multiplication of that rho a b will be equal to constant. Okay, so uh, so option C will be correct here. Moving next, an ideal flow of any fluid must fulfill what, again we already discussed that, so C option will be correct here. Okay, moving next, flow in which liquid particles has a definite path and the path individual particles don't cross each other, then that is called as your streamlined flow. Okay, so if there is a definite path and the path of individual particles don't cross each other, then that is known as your streamlined path. Okay, then question number 12, during the opening of a valve in a pipeline, the flow is what, unsteady. So you can say from time to time your during your opening of valve, the flow will be okay, not uniform. Okay, so flow will increase, so you can say it is depending on the time, so it will be what, B option will be correct, that is unsteady. So it will be not uniform, not steady and free vortex, So here B option will be correct one. Okay, so here B option, and as well as here also B option is correct. So here B and here B. So with this we have reached at the end of this lecture. So if you are not subscribed yet to this channel, do subscribe it and press on the bell icon so that you never miss any updates from this channel. So do like it, share it with your friends, with which it will be helpful for them. So thank you for watching.